Hello and welcome. Picture this. You're standing on a rooftop, maybe somewhere in Punjab, on a bright, sunny morning. You can feel the sun's warmth on your face, right? Well, that very same sunlight is being silently turned into electricity in millions of homes all across India. So, how on earth does that actually happen? In this explainer, we're going to demystify solar energy, tracing its journey from a curious lab discovery almost 200 years ago all the way to the sleek panels powering our lives today. Let's dive in. It really does feel like a bit of magic, doesn't it? I mean, that a simple, quiet panel on a roof can grab something as invisible as light and turn it into the power that runs our fridges, our fans, our whole lives. This is the big question we're going to answer today, and I think you'll find the process is even cooler than you imagined. So first, let's take a little trip back in time. Because even though solar panels on our rooftops feel like a pretty new thing, the story of solar power is actually a 200-year journey. It's a fantastic tale of scientific curiosity, incredible innovation, and really a revolution in how we think about energy. Okay, so it all kicks off way back in 1839. A 19-year-old physicist, Becquerel, is in his lab and discovers that just sunlight by itself could create a tiny electric current. What a moment! Now, fast forward over a century to 1954, scientists at the legendary Bell Labs create the first practical silicon solar cell. This was huge. It proved the technology could actually power the real world. And for us here in India, the massive turning point was 2010 with the launch of the National Solar Mission. That was our national commitment, and it has absolutely paved the way for the future. And what does that commitment look like today? Well, it means that by 2026, India has installed over 150 gigawatts of solar capacity. Now, to put that number into perspective, that is enough electricity to power tens of millions of homes. What started as a teenager's lab experiment is now, without a doubt, a nationwide energy revolution. So that brings us to the science. What is actually going on inside that panel when sunlight hits it? Let's break it down into simple, clear steps. And don't worry, I promise, no complicated math equations here. The whole entire process comes down to one key scientific principle, the photovoltaic effect. And you know what's cool? The name itself tells you the whole story. It comes from the Greek word phos, which means light, and voltaic, which has to do with electricity, so it's literally light electricity, the direct conversion of sunlight into power with absolutely no moving parts. I love this analogy. Just imagine sunlight isn't this continuous wave, but a shower of tiny little energy packets, kind of like invisible raindrops. These are called photons. And when these photons smack into the solar panel, they act like tiny little billiard balls, hitting electrons inside the panel's material and knocking them loose. Now here's where the real genius is. It's all about how engineers control those free-floating electrons. You see, a solar cell is made of two special layers of silicon. One layer, the N-type, is engineered to have a bunch of extra electrons. That's the negative side. The other layer, the P-type, is the complete opposite. It's designed with holes or gaps where electrons are missing. This makes it kind of hungry for electrons, creating the positive side. And this is where the action really happens. When you sandwich those two layers together, they create an electric field right at the border between them. This is called a p-n junction. The best way to think about it is like a one-way street or a one-way gate. When a photon comes in and knocks an electron loose, this gate forces it to flow in only one direction, away from the negative side and toward the positive side. And that organized one-way flow of electrons, well, that's exactly what an electric current is. Okay, so we've gone from a single photon creating a tiny current. But how does that little spark become the power that runs your whole house? Let's follow the flow of that electricity from the rooftop panel all the way to your light switch. As you can see, it's a pretty straightforward 5-step journey. Step 1, sunlight hits the panels. Easy enough. Step 2, the panels create DC, or direct current electricity. That's the same kind you find in a battery. Step 3, now, our homes don't run on DC. They run on AC, or alternating current. So a super important device called an inverter converts the DC to AC. Step 4, that AC power now automatically flows to your appliances. And finally, step 5, if you're making more power than you're using, that extra electricity gets sent out to the grid. And that last step brings us to a really obvious and important question. What happens at night? Or, on a super cloudy day when the sun isn't out? How does a solar-powered home get electricity around the clock? Well, the answer is surprisingly simple. For most homeowners in India, You don't actually need a big physical battery in your house. The electricity grid itself, it acts like a massive, free, and basically infinite battery for you. And this is all made possible by a really clever system called net metering, which is available in almost every state. So here's how it works. During the day, your home is running on your own solar power. If you make extra, it flows out to the grid, and a special meter basically runs backward, which banks credits for you. Simple. Then at night, you just pull power from the grid like you always have. But those credits you banked during the day, they're used to cancel out what you use at night. So at the end of the month, you only pay for the net difference, which for a lot of families can be really, really close to zero. All right, now that we understand the science and the system, let's take a minute to tackle a few of the most common myths you hear about solar energy and bust them with some cold, hard facts. This is probably the biggest one, right? The idea that solar power is some kind of luxury, just way too expensive for an average family. But is that really true anymore? The truth is, solar is way more affordable than ever before. Government subsidies, like the big PM Surya scheme, can slash the upfront cost. And with the savings on your electricity bill, the system often pays for itself in just 4 to 6 years. Think about that. After that, you're looking at more than 20 years of free electricity. In fact, it's now officially cheaper to build a new solar plant in India than a new coal plant. Okay, the next big myth is all about maintenance. People worry that these are complex bits of tech that are going to be a constant headache to look after for the next 25 years. But honestly, the reality couldn't be simpler. Solar panels are incredibly low maintenance. They have zero moving parts that can wear out or break. For most of the year, just natural rain is enough to keep them clean. Even in dustier places, a simple rinse with water a couple of times a year is all it takes. These things are built like tanks, designed to be workhorses that last for a quarter of a century with almost no effort from you. And there you have it. We've gone from a single photon of light knocking an electron loose, all the way to the national grid acting as a giant battery for your home. You now have the full foundation. You have the knowledge to understand how this incredible technology works, and now India is putting it to use on a massive scale. And maybe this simple quote just says it all. The sun doesn't send a bill, it just shines. At its very heart, that's what solar energy is about. Capturing a free, abundant resource that shines down on all of us. It's a powerful idea, and now you know exactly how we turn that shine into electricity. Thanks for joining me.